Circular loop of wire with radius 0.2 and resistance 40 is placed vertically. So let's write down our constants. Magnetic field is B, and our theta is 45 degrees. And then we've got a decreasing magnetic field of 3 times 1 minus 0.1 t. Determine the magnetic flux through the loop as a function of time. So let's start with A. The magnetic flux is equal to BA cosine theta, and this time theta does not equal 1. So our equation is 3 times 1 minus 0.1 t. Our area is a loop, so it's pi 0.2 squared, and then cosine 45. Notice how it's always to the angle from the magnetic field to the normal. If we multiplied all of these constants together, the 3, the pi 0.2 squared, and the cosine 45, we would end up with a flux of 0.27 times 1 minus 0.1 t. Okay, so we're determining the magnitude of the induced EMF. EMF is equal to negative d flux dt. We have an equation for flux with respect to time, so it's negative d dt of, let me first pull out my constant. So 0.27, and I'll leave the negative there, d dt of 1 minus 0.1 t, and then I can take the derivative of that, which is negative 0.27. Derivative of 1 doesn't give us anything, and so I've got negative 0.1, which is the derivative of 0.1 t. That gives me 0.027 volts. C is to determine the magnitude of the current. So here we've got current is equal to EMF over R. Luckily, those are values that we can just plug into our calculator. And the current is going to be 6.75 times 10 to the negative 4 amps. And then last but not least, it says determine the energy dissipated in the loop between t equals 0 and t equals 2. So that is the change in energy over change in time, which is change in time is 2. And since we're trying to solve for energy, that whole thing is equal to power. We do have an equation for power, which is equal to I squared R. So our equation here for power is equal to 6.75 times 10 to the negative 4 squared. Resistance is 40. And the answer we get here is 1.82 times 10 to the negative 5. I'm going to bring the dt to the other side so we can integrate. And if we integrate both sides, this is just a constant. We're going from 0 to 2. E is equal to 1.82 times 10 to the negative 5 times t from 2 to 0. That's just 1.82 times 10 to the negative 5 times 2, because 2 minus 0 is just 2. And so if I double 1.82, I get 3.65 times 10 to the negative 5 joules.